Hello everyone, we are from Gokaraju Rangaraju Institute of Engineering and Technology from the Department of Computer Science. Now we are going to present a mini project in text clustering using K-Mode's algorithm under the guidance of Dr. K. Anuradha ma'am and with the cooperation of our team members Prathyusha, Harisha, Ranjitha and Lavanya. What is data mining? Data mining is a technique for extracting interesting and useful knowledge from the huge data sources. Data mining is the use of automated data analysis techniques to uncover previously undetected relationships among data items. Data mining often involves the analysis of data stored in a data warehouse. Three of the major data mining techniques are regression, classification, and clustering. Text mining. Text mining usually involves the process of structuring the input text, usually parsing, along with the addition of some derived linguistic features and the removal of others and subsequent insertion into a database, deriving patterns with the structured data and finally evaluating an interpretation of the output. High quality in the text mining usually refers to some combination of irrelevance, novelty and interestingness. Typical text mining tasks include text categorization, text clustering, concept entity extraction, production of granular taxonomies, sentiment analysis, document summarization, and the entity of relating modeling, etc. Data clustering. Data clustering is an unsupervised technique for discovering valuable knowledge from data. It is a categorization or clustering of the documents based on the term frequency and other relevancy measures. Document clustering is a specialized document clustering problem where the objects are in the form of documents. The objective of the clustering process is to group the documents which are similar in some sense, like the type of document, contents of the document, etc. in a single group cluster. Document clustering aims to discover natural grouping among the documents in such a way that documents within the cluster are similar to one another and are dissimilar to documents in the other cluster. Exploring, analyzing, and correctness classifying are unknown the natures of the data in the document without supervision is a major requirement of document clustering methods. Clustering is a data mining functionality which groups the data given objects based on a similarity principle, that is, maximizing intra-classic similarity and minimizing the inter-class similarity. Document clustering is used for improving the retrieval effectiveness of the information retrieval system. Clustering can be implemented in two general categories: agglomerative hierarchical and partitioning methods. Types of document clustering. There are basically 5 types of clustering algorithms: hierarchical clustering algorithm, partition clustering algorithm, spectral clustering algorithm, grid-based clustering algorithm, density-based clustering algorithm. Pre-processing. We need to pre-process the documents and build vector space model before applying the algorithm. Pre-processing consists of steps: removal of stop words, stemming, prune the words that appear with low frequency, etc. Stop words. Many of the most frequently used words in English are wordless in retrieval and text mining. These words are called stop words. The, of, and, to are some examples. Why do we need to remove stop words? Reducing indexing file size. The stop words accounts 20 to 30% of total word counts. And to improve the efficiency. Stop words are also useful for searching and text mining. Stop words always have large number of hits. Stemming. The words that appear in documents often have many morphological variants in bag of words representing the documents. Morphological variants of the words have similar semantic interpretations. Coming to our algorithm, we represent the documents in the vector space model. K-Mode's clustering algorithm for text mining is chosen to group the documents into clusters for analysis. In the first pass, K-Mode's objects are randomly selected to initialize as a mode to each cluster. The remaining objects are then assigned to the cluster based on the similarity between the mode and the object. In the second pass, new modes are computed for each cluster and all the documents are reassigned based on the similarity between the mode and the document. The second step repeats until we get the same modes in the consecutive 2 passes. In the proposed algorithm, instead of choosing the mode randomly, select the mode in the following way. Choose the documents that are more similar and make each document vector as a mode to that cluster. Step 1. Procedure for choosing the documents that are more dissimilar. Generate the Boolean vector space model for the documents. generate the dissimilarity matrix, find the largest value in the dissimilarity matrix, assign each document vector as a mode to that cluster. Step 2. Assign all other documents to each other based on the similarity between the mode and the document. Repeat step 1 and step 2 until we get the same modes in the 2 consecutive iterations. Datasets. In this work, the experiments are carried out on one of the benchmark dataset, that is classic dataset collected from UCI.kdd repositories. There are 4 different collections: CACM, CISI, CRAN and NED in classic dataset. For experimenting, 800 documents are considered after pre-processing the total 7095 documents. The documents consisting of single words are meaningless to consider as a document dataset. So, the documents with the words less than the mean length of the documents belonging to that category are deleted. This is file reduction on each category is applied. After applying the file reduction strategy, we go to the valid documents. 200 documents from each category are collected from the valid documents, summing up to 800 documents. For the execution of a project, we have selected 800 pre-processed documents of the categorical data. The pre-processing, stemming, stopword, stemming are applied and Boolean vector space model is obtained. We have applied cosine function to generate the similarity matrix. The matrix contains clusters of more similarity are grouped together. The number of clusters formed are applied. Similarities measures depend on the input given to the user. And finally, our code is being rated based on our accuracy. As no other algorithm is in this world is ideal, the accuracy may not be 100%. But we can justify the effectiveness of our proposed algorithm by using standard cluster quality measures like F measures, purity and entropy. Conclusion. Document clustering using K-modes forms clusters which are more related and thus helps in producing useful characters compared to clusters produced by the other clustering algorithms of K-means family. The clusters are formed for the 3 input representations, that is Boolean, frequency, using all the similarity measures, Manhattan distance. Varied results are obtained for a same representation with different similarity measures. Future enhancement. The clusters obtained can be made concept or context grouping of documents by using some extra criterions like synonyms or relations between the words. The form can be more effective by taking only few important words rather than taking all the words. Thank you.